So we looked at expanding logarithms, and what we looked at is that if I have the operations of multiplication, division, or exponents, I can move this direction to expand those logarithms from a single log into many logarithms, and these operations are going to trade out for one of these on the right. So that's what we looked at yesterday. What we're going to look at today is going the opposite direction. So we're going to take an expression that has many logarithms, and we're going to condense them into a single logarithm. The reason why this is especially important is if I give you an equation to solve, like log of x plus log of x plus 2 equals 100, okay, logarithm, you can't combine them like terms. It's not like they have the same coefficient. Remember what we talked about is that word log represents a function, just the way square root represents a function. It's an operation. So it doesn't have any numerical value. So you can't just combine those and get log of 2x plus 2. That's not allowed and it's not equivalent. So instead, what we have to do is use these condensing properties to be able to combine them into a single logarithm. So if we turn the page here, what we're going to do to condense these is you'll always want to go in this order. When you condense, the first step that you want to do is put back your exponents. You'll know that there's going to be an exponent because there'll be a coefficient in front of the log. So that's the first thing, is put back your exponents. After that, you're going to work left to right in pairs. And you can only put together one operation at a time, so you'll go in pairs. Lastly, don't forget, just like when we expanded, that anything that can be evaluated should be evaluated. Anything that can be simplified should always be simplified. And so we'll keep that in mind moving forward. Watch out for things like parentheses because that'll break your order of operations. Normally we'd go left to right in pairs, but if you look at part C, that's got parentheses. So that tells me I have to put those together first, even though that's not going left to right. So let's look at example A. So the first thing I'm going to do is look for any exponents that need to be put back. And I see this coefficient of 3 right here. So that tells me that this needs to become a third power. So I have the log base 4 of 9 plus the log base 4 of 2 to the third minus the log base 4 of 3. Okay? Now, as we go, it's kind of helpful to simplify the things that we can. So for example, 2 to the third is going to be 8. So we want to think of that as the log base 4 of 8. So now we're going to go left to right in pairs. So my first pair from left to right is combined using addition. If you look back at our little cheat sheet, that little box, we're going from right to left this time because we're condensing. So addition moves backwards to multiplication. When we do that, we're going to bring it down to just one log. So the log base 4 of, this is going to be 9 times 8. And again, the 8 is coming from right here because that's what 2 to the third is equal to. And then we still have minus log base 4 of 3. Now again, we see something here that we can simplify. 9 times 8 is really equal to 72. So we're going to think of that as a log base 4 of 72 minus the log base 4 of 3. Now when we look left to right, we see that we have a subtraction. Subtraction moves back to division. Once again, one logarithm, log base 4 of 72 divided by 3. Now 72 divided by 3 comes out evenly. That gives us the log base 4 of, I think, 24. And then we want to check, is there an exponent so that 4 to some power equals 24? And there's not. So that's where we're going to stop. So once again, our first step was to put all the exponents back. You're looking for coefficients like that 3 there to move those up. And then you're going to work left to right in pairs unless there's parentheses or something that's going to tell you not to go in that order. So why don't you go ahead and pause the video and try example B. It's really similar. The natural log doesn't change anything, and see what you can come up with there. So the first step was to put back our exponents. This 3 goes up, and so it becomes a 3 to the 3rd power. That's where I get this 27. Next, we'll work left to right. This addition here is going to trade out for multiplication, and when I do 4 times 27, that's how I get 108. And then lastly, we have the natural log of 108 divided by 12, which is the natural log of 9, and that does not come out evenly, and since it didn't tell us to evaluate, we don't want to put that in our calculator, even though with the natural log we can. So the last example here has variables, and I think it's probably even easier with the variables because you don't have to worry about simplifying all of these expressions. So we're going to do the same first step. We're going to put the exponents back. So we'll start by putting these two back. So we have the log base 10 of x squared minus the log of y plus the log of z to the 5th. Now, like I said, normally we'd go left to right in pairs, but since those parentheses are there, that tells me that I need to put these two together first. So I'm going to leave my log of x squared minus the log of, I multiply here, so yz to the 5th is what I get. And now because we're subtracting, we're going to divide, so we get the log of x squared over yz to the 5th. And there we go. So then the question always is, where do I need parentheses? Where do I not? If it's a single term that doesn't have a whole lot of stuff going on, like log of x squared, don't really need the parentheses there. In the second one, I have more than one variable there, and so it kind of opens the case for ambiguity. Is it the log just of y and then times z to the 5th, or is it the log of the y and the z to the 5th? So it doesn't ever hurt to put parentheses. It's never going to be wrong to add extra parentheses, but it might be wrong if you leave them off. So it's a good habit when you have a lot of things going on to just put them in parentheses to keep track, okay? The last thing is the change of base formula, and I'm going to go ahead and put that in a second video. So you've seen the condensing, you can get started on that, and then the change of base formula is the last thing you'll want to look at.